When a standard passenger car tire reaches the end of its life, it usually settles into a scrapyard or a municipal recycling center. But in Formula One, the rules of ownership are different. A multi-million-dollar racing team doesn't actually own the rubber on its cars. They are temporarily using highly controlled assets. Once a race weekend concludes, teams are strictly prohibited from keeping a single tire. Whether it's shredded to the casing or perfectly brand new, every unit must be returned to the manufacturer. This raises a specific logistical question. Why does a piece of spent motorsport polymer require maximum security handling instead of standard industrial disposal? The governing bodies mandate a zero-leakage supply chain, where every single gram of rubber is tracked from the factory to the track and back again. This protocol governs the entire life cycle of the tire, creating a rigid logistics loop that begins long before the cars ever leave the pit lane. Understanding this system requires looking at the physical hardware as a high-value data source that must be contained within a secure network. The security protocol starts with a strict monopoly. Pirelli operates as the exclusive global manufacturer of every racing tire used in the sport. Unlike standard motorsport sponsors who simply buy branding space, Pirelli is the active chemical engineer behind the hardware itself. To maintain the loop, every unit is produced in synchronized batches, stamped with barcodes and embedded with radio frequency identification tracking chips. Once at the track, the FIA, the sport's independent governing body, takes control of distribution through a process called blind allocation. If a team could hand-pick their tires, they could measure microscopic manufacturing tolerances to select a mathematically optimized set. Blind allocation removes that variable. Randomized distribution means no team can secure a hardware advantage before the rubber touches the tarmac. The logistical pressure peaks the moment a racing session ends. An engineering team is highly motivated to get their hands on a used compound for laboratory analysis. These physical wear patterns, graining and blistering, record precise telemetry on how a car's suspension interacts with the track. Keeping this degraded rubber allows rival engineers to reverse engineer Pirelli's proprietary formulas. This creates an asymmetric data advantage on the grid. A massive factory team equipped with advanced metallurgical labs could extract far more technical insight from a used tire than a smaller independent constructor. The mandatory 100% return rule acts as a hard cap on this data acquisition. Confiscating the hardware ensures technical parity, guaranteeing that races are won on the track rather than through post-race chemical espionage. To secure the hardware, the pit lane transforms into a high-speed reverse logistics pipeline the moment the race is over. Step 1. Tires are demounted from team wheel rims. Step 2. Manual RFID verification scans by Pirelli technicians. No exceptions. Even unused tires pass through this exact pipeline. Finally, Step 3. The allocation is locked-in secured crates for global transport. The paddock operates as a secure retrieval facility designed to immediately neutralize any further team access to the hardware. Once those secure crates leave the track, they move to the final stage of the pipeline. These racing compounds are engineered for extreme thermal windows, giving them a chemical composition that is vastly different from commercial rubber. Because of this complexity, they cannot be processed in traditional municipal recycling facilities. Instead, the manufacturer uses a specialized process known as controlled pyrolysis. Pyrolysis applies extreme heat within an oxygen-free environment, shattering the complex synthetic polymer chains without triggering combustion. This safely manages the environmental hazard while simultaneously destroying the chemical signature of the proprietary formula. The tires are converted into secondary industrial materials like oils and raw carbon black, rather than being remade into new racing tires. This controlled destruction is the final security measure, shielding corporate secrets while neutralizing the industrial waste. The ban on retaining used tires is a core part of the sport's technical architecture, functioning as a perfectly sealed circle. At its origin, the manufacturer's chemical formulas are insulated from reverse engineering. On the track, technical advantages between competing teams are neutralized by strict hardware control. And at the end of the line, hazardous materials are destroyed under total manufacturer oversight. A physical tire casing in this ecosystem is a critical intelligence asset, and it demands the same level of strict access control as a digital database. In the world of elite engineering, managing the destruction of physical hardware is just as important as the manufacturing process itself.